So we've talked a little bit about what margin of error is, and it's a way of giving a quantifying the actual sampling error. Now, sampling error is very much affected by how big a sample that you have. The bigger the sample that we have, the closer you're going to get to what's going on back in the population. And so a big sample size is very, very important because it lessens the margin of error. Now, we talked about the fact that there is a formula for calculating margin of error, and it's basically this formula here. So you're taking 1 divided by the square root of n. Now, n is the population size. Okay, that's what n stands for always. It's just your size of your population, or sorry, not your population size. I take that back. It's your sample size. Okay, so let's get that right. Sample size. So n is your sample size. Now, the bigger your sample size is, the less variability you get in sampling. And so the closer and closer you will get to what's actually going on in the population. Now, we always turn this into a percentage, always, always. So we're going to multiply that by 100. So one way of just writing this as a sort of simple, not to forget to multiply by 100, is we just basically go 100 divided by the square root of n. It's just a short way of doing it. You're doing exactly the same thing as you're doing up here, but you're doing it in one step. And n is your sample size. So let's take a look at how this works. So if you take a look at these examples down here, we've got a sample of 300 students, which is a reasonably good sample, but it's quite small. And what we end up having is that we end up having basically the middle of this, which is, you know, sort of the 33%, if you will. What happens is that in a small sample of, say, 300 students, you have a sample proportion will lie somewhere between 24 and 37. If you take a look, that most of our samples, we cut off the sort of extreme ends, and most of those values, most of those samples, these are all samples, are giving us a range of values or percentages somewhere between 24 and 37%. Okay? And so that's sort of a range. If you go 37 subtract 24, that's a range of about 13, right? So if you take half of that, about the middle of 13, sorry, if you take 13 and you divide it, you're going to get about, 6.5, somewhere around there. So basically you're saying that with this particular sample, we're going to have basically the sample proportion will be within 6%. So plus or minus that 6%. So we'll have a proportion that's sort of in the middle, and then we'll have something that's about 6% higher than that or 6% lower than that. And so we can calculate that margin of error based on the sample size by simply doing the 1 over divided by the square root of 300. We square root the sample size, we times it by 100, and we get a percentage. So about 6%. So we're saying that that's what's going to happen for a sample size of 300. Now, if we do a sample size of 1,000, it's a tiny bit different. You'll see that the values are much more compact. And in fact, the values actually range between 26 and 34%. So we've got less of a range with a bigger population. We've got less variability in the sampling. And so now when we work it out, we work out a margin of error to be only 4%. So basically we're saying that the range of values, or the range of percentages that the population could sort of, our sample is going to fall somewhere between 33%, and it's going to be sort of plus that 4% or minus that 4%. So we're pretty comfortable that, about 95% confident that the sample parameters will fall within 4% of what's actually going on back in the population. And so sample size has a great deal to do with our accuracy and how wide a margin of error that we're going to get. We don't want to have too big a margin of error. At 300, we had a margin of error that was 6%. At 1,000 students, a sample size of 1,000, we get a sample size, or a margin of error that's about 4%, which is quite a bit less. And that's because we get less variability. All right? So this is how we calculate margin of error with a single comparison. So we have a single sample that we're looking at, a single poll that was done, and then we're just going to take a look at what would be the margin of error in this particular situation, or check out if the margin of error is in fact correct for this particular sample. Now, in this particular example, we were never told how big the sample actually is. We're given the margin of error, but we're never actually told how big the sample is. And we will have to deal with that. In most articles, they will tell us what the sample size is, and so we will be able to do some calculations. Now, one note for margin of error in this rule of thumb formula that we use. It only works for proportions or percentages that are between 30% and 70%. It will not work. We cannot use the rule of thumb for proportions or percentages that are less than 30% or higher than 30%, because the rule of thumb is sort of based on the proportions falling somewhere around 50%. All right, and so anything between 30 and 70 is pretty close to that 50%, and it works out fine. If you get something that is less than 30%, then you're going to have the rule of thumb will calculate a margin of error that's too big. And if it's bigger than 70%, you're going to get a margin of error that is also going to be too big. So we have to be careful, and we have to be mindful that we're only going to use this rule of thumb formula when we have the percentages, like this percentage of people that vote for Labor has to fall between 30 and 70%.